Hi students, welcome to the solutions of task 1 of AECPRE. Okay, I had given few problems to find out what is the power dissipation in each of the resistor, and of course whenever you want to find the power dissipation I should know what is the resistance value and the current flowing through that, and it was also asked to find what is current flowing through each of the resistor and voltage across each of the resistor. And of course this is a second circuit. Of course this is the second problem where we are asked to write the KVL and KCL for this. Okay, now since it's a pretty simple problem, I think most of you might have done this problem, so we can write a KVL for this starting from this node. Since there is a voltage rise, I can write it as plus, and we are assuming a current of I flowing through this. Okay, the drop is I into R1, so since it's drop plus minus, it is this. Okay, maybe what I can do is I can just write it here, so that maybe these are all very simple, but still I want to ensure that all of you get this. Okay, what I have is this is the circuit I have. This is R1, R2, so this is a current we are assuming. So this is V1, this is a 5 volt. So this, okay, let me say it as maybe, okay, V1, and or let me say it as V in. So since this is R1, so let me write the voltage across this as V1, let me write the voltage across this as V2, and this is grounded. So the resistance value given is 1 kilo ohm and the resistance value given is 2.2 kilo ohm. So of course if you start from here, so I have to write the KVL for this. So whenever I am writing KVL, so you have to start from a particular node, you have to come back to same node. So I am starting from here, so I will come back to same. So I have to complete a loop. So when I am starting here, so since it is voltage rise, I will write it as plus V in, and there is a voltage drop here, it is minus V1, and there is one more voltage drop, it is minus V2, and since you have completed the loop, it is 0. But what is V1, V2? So V1 is actually I into R1, so I can write V in minus of I into R1 minus of I into R2 equal to 0. I can write V in, I can take I outside, I can write R1 plus R2 is equal to 0. Therefore I can write I is equal to, of course this is very simple, so don't think okay, so why we are doing such a simple stuff. So just try to make all of you familiar with all these things. So it is 5 by, so now we have it as 3.2 kilo ohm. So now it is 5 by 3.2 exponential 3 is actually 1.5625 milliamperes is the current. The same current flows through both the resistors, so that we can know what is V1, which is nothing but this into 1k, so that is 1.5625 milli into 1k is 1.5625 volt, and V2 is same current multiplied by 2.2k. I can simply write as 2.2 exponential 3, it is 3.4375 volt. This is what I have for V1, V2. So we can find what is the power dissipated across each of the resistor. It is either I square into R1 and I square into R2, or you can write it as V square by R1, which is and V2 square by R2. So V1, V2s are these corresponding voltages. So both are. So if you say it as this is P1, this is P2, power dissipation across P1, P2. We know that energy cannot be created or destroyed. Whatever is the power that is there will be dissipated across this. If I say it as P in, so then P in is equal to P1 plus P2. So then what is P in? P in is actually equal to voltage that is there here multiplied by the current that is supplied, which is nothing but I, which is now 5 into 1.5625 milli. Okay, this is what is there given in this solution. All of you are very comfortable with this, so you can easily do all these things. Now, of course, similar to this, so we can do this also. Here you can see you have two resistors in parallel. I can write the equivalent resistance, which is R2 parallel R3. So we know that when two resistors are in parallel, so their effective resistance is the multiplication of these two divided by the addition, or you can write it as 1 over R2 plus 1 over R3 whole inverse, which will be coming out to be 909.09 ohms. So once you are through with this equivalent resistance, you add these two, that will become the overall resistance. So voltage by resistance will give you the current, so which is this current I1. Now here this is I1, so in order to find I2, I3, so we have an equation here. If you know the overall current, the current flowing in the other branch, which is R3 here, suppose if you want to find what is the current through R2, so then you write the overall current I multiplied by the resistance of the other other resistor of the parallel combination divided by the sum of the two resistances. So if you do this, you will get 0.9 milliampere for this, and in order to find this I3, you can simply subtract I2 from I1, or if you want to find I3, is the overall current, which is I1 multiplied by the resistance of the other side of this parallel combination, that is R2, divided by the sum. So this comes out to be 9 milliampere. Of course, this also you can make out when the resistance is small, more current is flowing. When the resistance is more, lesser current is flowing. So this is an indication that this is a correct answer. And okay, that's what is this which we almost got this on. So, and again, so as we did in the previous case, voltage drop across each of the resistor, power dissipation, and all those stuff. Let us try to second. Okay, let me continue. So let us try to see let us verify all these things using LTSPICE. So this is the LTSPICE. Those are not yet installed, please install it. It is very handy to use this for understanding the concepts thoroughly. So let us start a new schematic, and since we know that this is a circuit what we are supposed to simulate, which is a very simple circuit, so I will take two resistors. So I will write it. Control R is the command to rotate it. Again, I'm rotating. So there are two resistors placed, so I have to right click on my mouse so that it goes off. Next I will use of course components are here, so I will go for a DC power supply, which is there in this miscellaneous folder. You can see there is a battery. I can select it here. I can place this. So actually this is, if you see, this is component. All components are housed here. So if you go to this, there are so many folders. In these folders there is a miscellaneous folder. In the miscellaneous folders there is a battery. So that's what we have placed here. And okay, let me put a ground also here, and let me do the connection. For doing connection, it is I have to do the wiring. So I will start from here, go like this. So I'll just run till here, and then I can see, even though I'm just passing through this resistor, so when it makes a connection, it just actually not pass through that, it will break itself. You can see I'm done with the circuit. Let me connect the ground also. You can see the moment when I connect three lines, there is a node coming immediately. And let me make this as 1 kilo ohm. So 1k is the, of course you can type it as k means kilo, and this is again the value, which is now in this case 2.2 kilo ohm. no need to say it as ohm, by default it is ohms. The voltage is now 5 volt. The voltage is now 5 volts now. Okay, it is done here. So let me name it as V in. So that's what we wrote in the notebook, or in the okay, here we note it as V in here. So this is V in. So let us now run this. So before I run, I have to say what analysis that I am doing. So that will be done here. This is what is configure analysis. The analysis that I am doing is transient, that is after some time. Okay, with respect to time, how does the circuit behaves? So let me give it time as 1 millisecond. Let me start saving the data from 0th second. So let the time step be 1 microsecond. Micro is U. So I'm done with this. So this is my transient analysis I'm doing. If I run, okay, now I'm getting, you can see the time is running from 0 to 1 millisecond. That's what I specified. Now I want to see many things here. So now, actually I want to see a current which is flowing in this opposite direction. Suppose if I come close to that component, you can see this is my current direction. So since the current direction is exactly the reverse how I wanted, so what I'll do is I will select this. Okay, I will just say escape. I will select this. So how do I select this? So there is, you can see here, this is move. So you can just click on this and then select it, and you simply rotate this, Control R twice. I will connect this, and this also I will just connect it ulta. So now if I run, you can see the current direction is as per the expectation. So we actually expected current to flow. Of course, current will going to flow in this direction from left to right of R1, because this is at higher potential, this is at lower potential. The current goes from higher potential to lower potential. That's what is this here. You can see this is also same thing. Now I can see what is the current flowing through this. If I click on this, you can see a current is flowing here. So this is the magnitude of the current. This is current through R1. So that's what is IR1. You can also see what is this IR2. Can you see this is IR2? Okay, let me change the color. This is IR2. You can see this is red and this is green. Actually red and green are overlapping each other because the current is, okay, let me show you how to get that cursor. So now you can click on one of the cursor. You can see if I click on this cursor, a cursor will come. If you click on this twice, you will get two cursors. You can see there are two cursors, cursor 1, cursor 2. Both are lying on IR1 and IFR1. So you can see the current is 1.5625 milliampere. That's what is, we got it here. So you can see this is what is the current that what we got. So same current is flowing here, so which is obvious. Now the current flowing through this is same, that is both the resistors is same. Let me see what is the voltage across R1 and R2, that is VR1, VR2. So for that, what I do is, let me just remove one of them. So for removing, you can see there is a delete mark here. So you can just come here and then cancel this, because both currents are same. So if I want to measure the voltage across any resistor, so you know that to measure the voltage, so this is how you do it. So you need to have plus here, minus here, you need to have plus here, minus here. So now let us do the same thing here. So what I'll do, I'll just come here and then where is my circuit? Okay, this is my circuit. Let me just make this bold. So this is plus minus. So how do I get that plus minus? You can see if you come close to this, whenever you are running, so whenever you come close to this, can you see there is a red one? Click on this and you hold the mouse and then come here. Can you see there is a minus coming? So now this is actually, if you can see now, this is I'm actually placing, so okay, let me just change this to a different color. Blue is somehow not visible. Sorry for that. Now you can see there is a voltage displayed here. It is V of N001 comma N002. So this is node 1, node 2. So between these two nodes, so this is the voltage, which is nothing but V1 as we wrote here. So the V1 is nothing but Vn001 comma N002. So that voltage is actually 1.5625 volts. So shall we verify that? So I can click on this, see the voltage 1.5625 volt. And what is the current? So now you can see both current and voltage. Now I'm using only one cursor, so at a particular time, so I can use another cursor. Now both the cursors are on same voltage. Now if you want to place one cursor here, one cursor there, so I can just click one here. You can see now cursor 1 is on current through resistor R1, the cursor 2 is indicating the voltage across resistor R1. Now that's what we have actually verified. This current is verified that the current is 1.5625 milliampere. The voltage across this is also 1.5625 volts. So let us try to verify what is the voltage up across this R2. To do that, again we actually said that, so there should be a plus minus here. So now, but actually this is plus, this is minus. So this minus is same as ground. So no need to have plus and minus. Even if you place only one cursor, since it is always with respect to ground, this voltage at this point itself, I'll get a voltage across R2. Now you can see the moment I click on this, I'm getting Vn002. Vn002 is voltage at this point with respect to ground, which is nothing but voltage across resistor R2. So as per our calculation, what is VR2? It's actually 4375. How do I measure that voltage? Again, let me change this color to some different one. You can see now this is that voltage. Now see here, this is the voltage of resistor R2, this is the voltage of resistor R1. If you add these two, that will become 5 volts. So that will become 5 volts. So this way, now what does this actually indicating? This is indicating current through the resistor R1. This is indicating voltage across resistor R2. This is indicating voltage across resistor R1. So that's what is these things. Now how about the power dissipation in resistor R1, R2? For that we know that it is I square into R or I into V. So I into V. So since we know this voltage across resistor R1 and voltage across resistor, this is across R1, this is across R2. If I multiply this with current flowing through that will become the power. So what I'll do here is, instead of making I square into R, it's also possible to measure this. What is power here? Can I say it as V1 into I1? Shall I say it as V2 into I1? Because I1 is the same current flowing here. So since I have this current, I know I have the voltage also, I simply multiply these two. So that is also possible here. So what I'll do, I will right click on this. Can you see I can add traces? So the trace I want to add is of power, but unfortunately I don't have the power as a parameter, but I can multiply, what is that, Vn002 multiplied by how much? Multiplied by I of R1 or I of R2. If I multiply these two, am I actually multiplying this voltage, that is V2, into the current I1 or I2, which is same? So you are supposed to get a power of how much we are supposed to get? So as per our calculation, I should get a power of 5.371 milliwatts. So let us verify that. Let me just verify that here. Since we have typed both of them, if I say okay, you can see this is where is that power I'm getting. You can see this is that power. And okay, let me take out this current now. So let us delete this trace also. Let us delete this also. See now what is the power? Can you see the power is, okay, let me just put it, oh, where is the power? Okay, let me add the trace. How to add the trace? You just add traces. So it is N002 multiplied by, so this is the power. You can see this is the power. See now what is the power? So power is 5 point, that's what is the expected power. How much was the power expected here? Across resistor R2, across resistor R2 power expected is, you can see here, this is, you can take the cursor, see here, see how much is, can you see it is 5.6, 5.36, so that's what is here. See here, see this 5.371 milliwatt. So this is how you can able to verify the power dissipation across resistor R2. You can also find it for across R1. For across R1 I have to type this, because, so what I'll do is I should be getting this 2.44 milliwatt also. So how do I do that? Again I will add a trace, so it is now okay, open the parenthesis. I'm opening the parenthesis, which is now N001 minus, this is minus N002, close the parenthesis, multiplied by IR1. If you do this, okay, there is a syntax error because the parenthesis is not matching properly. Let me close it here. Okay, this closure has to happen here. Okay, let me close it here. This is not required. Fine. See now, this is that. Can you see it is 2.44 milliwatt? That's what is expected. Can see it is 2.44 milliwatt. So this is power dissipation in resistor R1. So what is the overall power dissipation of the circuit? So as you see here, so it is this plus this is actually this, which is nothing but the power dissipation of the entire power supply, which is nothing but V into I. So how do I measure this V into I? So it's very simple. What do I do now? So you can add a trace which corresponds to N001, which is the input voltage, multiplied by the current, multiplied by any one of the current, because you have only one current. Okay, what I'll do is I'll remove all others. I will, okay, let me remove this. I will delete this trace. I will delete this trace also. Let us simply verify all the three powers. You can say this is one power, which is 3 point so and so, and what is this power? This is actually 2.4, and this is 7.81. These are the three different powers what we have. So I can just see here. You can see one power is, this is the overall power, 7.81, and across R1, across R1 power dissipation is 2.44. If you want to see it across this, it is 5.37. So this way we can able to, even though we don't have power as one of the parameter to be measured over here, but when you are multiplying the voltage across this multiplied by the current, so you will get the same power expression, power value. Okay, now you may have to save this. Okay, before you simulate, you can save it. So I will save this. What I'll do, I will say it here. So whenever you are saving, please make sure that, okay, let me save as let me say it as AECPRE. It is assignment 1, and this is first one, and it is okay, it is the first and A. So I'm done with this. I will save it. Now what is the next circuit? Of course, now this is how you can do it. So you can open the second one, you can close this, So before you start, you can save it as this is maybe in the same. Now it is B. Save it. So let us open the circuit. This is a circuit what you have. Maybe you can just put this aside so that we can simultaneously draw the circuit. Okay, let me draw it here. So what you're supposed to have, okay, let me now draw the circuit. So you need to have a resistor, Control R, place one here, one more resistor, and there is a battery required. Go to components, and the battery, battery, place it here and do the connection. Of course you can zoom out by the cursor. Where is the ground? This is my ground. Okay, ground is a must in your circuit. Start from here. I can go till here and then do this connection, complete this, do this parallel, and then do this, connect this to this. Now you can edit the values. I think okay, you limit as whatever. I think this is 10 volts what you have, and these resistors are of what value? One is 100 ohm, 10k, 1k. So this is 100 ohm, this is 10k. I need to edit the value, not the number. So it is 10k, and the other one is 1k. Am I correct? Okay, these things. Okay, let me do it quickly. So how do? I want to do this analysis. It's a transient analysis. Make it as 1 millisecond. Make it as 0. Let it start from 0 second, the saving. Print step, let it be very small compared to the final time. You can now run it. For running it is this. So let us, you can see now the current is again showing in the opposite direction. Let me rotate this. So what I'll do, okay, escape. Now it is move, that is simply rotate it twice here. Let me rotate this also so that I can directly get the current. Okay, now if I run it again, okay, it's already running. I can see this is the current 9.9 something. This is ulta. Okay, I would have not rotated this. Okay, I will again do this. M, Control RR. Now, okay, let me again run. This is one more current. This is the third current. If you actually see these currents, which is I1, I2, I3s, okay, we already have the expression. We already have the values of all the three currents. So the three currents are, okay, these are the currents. You can see one of the current is 900 microampere. Okay, one is, this is current through R2. Current through R1 is 9.9 milliampere. This what is 9. This is that overall current, which is 9.909. Okay, this is that first current. Next it is this microampere, matlab, okay, this will become here this IFR1, it is 9.909. Next it is current through I2, which is 0.9 milliampere, nothing but 900 milliampere, and current through R3 is actually 9 milliampere, 9.009. That's what you have here. You again see the voltage across each of the resistor. So how do you do that? Again, you measure the voltage across this and voltage across this. So this is what is voltage across one of them, which is 990 millivolt, which you found out to be here. Where is that 990 millivolt? Which is that's what is this. This is 990 millivolt, 990 voltage across R1. That's what is this. And other voltage is actually I would have measured. Okay, this is the voltage corresponding to 9. So this is one is 9 volt, other is 990 millivolt. So if you add these two, that will become 10 volt. Again, you can do the power dissipation. This voltage across this multiplied by current of this one, voltage across this, current multiplied by current through this one, you'll get the power. Okay, start using the LTSPICE. Of course, even though it's a very simple circuit, but you will have a lot of learning in each and every thing. Okay, so maybe when you start doing, okay, get to know why it is dot tran, so how to edit the values, get used to it, get used to use the cursors effectively, so that you can actually get the values on this one directly. If you want to cancel, simply cancel it here. If you want to delete anything, go there and then simply say delete or backspace. So that will going to have a scissor like thing, which will going to delete the cursors. Okay, then thank you. We will see the solutions of second one in the next video. Thank you.